The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So we're going to work through problem number 3 in exercise set number 3. And in this problem, it asks to roughly sketch what you believe to be a typical graph of the functions below. And there's 3 different parts, A, B, and C. We're going to go through each one of them, starting with part A. And in part A, it says to basically sketch the graph of the function where the temperature outside today as a function of the number of hours after midnight. Okay, and so basically we want to sketch a graph of the temperature as a function of hours after midnight, and so we could represent that as T of H. And we can create a coordinate system where we have hours after midnight on the x-axis, and we have the temperature on the y-axis. And if we think about this, it's going to be the number of hours after midnight. And so we know that at midnight it's going to start at some temperature, okay? And then as the time goes on, the temperature is going to decrease, okay? So the temperature is going to decrease, and it's going to continue to decrease until sunrise. And then at sunrise, the sun's going to come out. So at sunrise, the sun's going to come out, and it's going to start heating the temperature back up. Okay, and so we should get a graph that looks something like this, that relates temperature to the number of hours after midnight. So now let's do part B. In part B, they say the percent a student scores on an exam as a function of the number of hours studied. Number of study hours. All right. So again, we're trying to associate a score to the number of hours that a student studies. And so if we use S for score and H for hours, and we're trying to, we can denote that we're trying to have a function S of H. And we can create a coordinate system where we have hours, study hours on the x-axis, and the score on the y-axis. And we know that we know a couple of things. We know that the maximum that a person can score would be 100%. So this would be in a percentage, okay? And we know that the maximum is 100%. So we can't go higher than 100. And we know that if a person studies 0 hours, they're probably going to do worse than a person who studies, let's say, 5, 10, or 15 hours. And we know that as the number of hours studied increase, then the score should increase. So we may get a plot that looks something like this, where as the number of hours increasing, the percentage or the score will increase up until we get to a point where we reach 100%. And it doesn't matter how much a person studies after a certain amount of hours. Let's say they studied 30 hours out here. A person who scored 30 hours is going to score 100%, and a person who scored 35 hours is going to score 100%. So you definitely don't want to study 35 hours to get 100% if you can study 30 hours. So this is what the plot of this function would look like. So now we're going to work through part C. And this one says the vertical distance D, capital D, from your hand to the nearest object as you move it horizontally across your desk and over a textbook and they give a picture okay, and basically we have a desk So this is our desk, and we have our hand, and we know that the distance between our hand and the desk is D. We also have a book, okay? And if we were to move our hand as we slide our hand across, okay, then the distance between our hand and the book we're going to call little d, okay? And so we can set up a relationship between the hand position and the distance away from the closest object. And we can do that by setting up a coordinate system with hand position on the x-axis and our distance on the y-axis. Okay? And we see that as we move our hand across the desk, the distance is going to be constant until we get to the book. Okay? And so if this is the edge of the desk, we start moving over until, and this is distance D, until we get to the book. And when we get to the book, our distance is no longer D, capital D, to the closest object. The closest object is now the book, which is lowercase d. So that's going to be this distance here. And as we continue to move our hand across the book, the distance will remain constant. And then we will, and then as we move our hand again across the desk, the distance to the closest object again becomes capital D. And okay, and so this will be the plot for this particular function in part C, and we could label this as the edge of the book if we wanted to be more detailed. All right.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.